All right, in homework 5.5, we are finding volumes using known perpendicular cross sections. Here's the basic idea, is if we have some region that's an area, and we know the, and we can figure out the perpendicular cross section, what the length of that is, and we know the area of each of the shapes that is sticking out, we can use this formula we have that is the volume is equal to the integral of area for different at different x's. So if you add up all the areas, you get volume. So that's what we're going to be using here. Let's look at number 2. It says a solid has a base in the xy plane. This is a calculator problem, so you should immediately be looking to do stuff in the calculator. And it wants us to find some volume of this solid. And let's get a sense of what it is first. It's the graph of natural log of x equals 5, and the x-axis. So here's what we've got. We've got natural log of x equals 5, which it's hard to graph, but it's right here. This is where x is equal to 5. And so if I want to look at what the base is, it's the integral from, it's not from 0 to 5, it's from 1 to 5, because that's where it intersects with the x-axis. So this is the base. And it says the areas perpendicular are squares. And so what we end up with is these squares sticking up. So the formula is going to be the volume is equal to the integral from 1 to 5, because that's where it begins, of, well, what is the area of each one of those squares? At any given point, the height of the square is natural log of x, and so since the height is natural log of x, the area of the square is natural log of x squared. So that's what we're doing. We're just going to type into our calculator, math, it's the integral from 1 to 5 of natural log of x squared dx. I want to show you another way to type this in real quick. We could also press the integral from 1 to 5, and instead of using x squared, we already put in this y variable, and this is a silly one to do this on because it doesn't save us a lot of time, but later this will be very useful. We could just press variables y1 squared, because y1 is the height. And that makes for an easy way to type it in to make sure we're actually squaring the right thing. Let's do one more. Let's see. Here we've got, in 5, we've got this region. And again, I'm going to graph it. It's a calculator problem. So 20, I guess I should type it in like this. 20 over 1 plus x squared. And the horizontal line y equals 2. And so we've got this graph between the first and second quadrants. So that's this quadrant and this quadrant, bounded between the line y equals 2 and this line right here, this curve right here. And the cross sections are semicircles. And so what that looks like is, so we've got this area, right? And semicircles, we need to find the area of a semicircle. And the area of a semicircle is pi r squared divided by 2. The tricky thing about this one is the r isn't this length. The r is this length divided by 2, because the radius has to be half the distance. So this is going to be pi times the top minus the bottom divided by 2. That is what r is. This is the radius squared over 2. And this is one where it's going to be a lot easier to try to type it in. So the first thing we're going to do is we're going to graph it. We're going to find the intersections. That's a skill we need to be good at. And the intersections go from 3. The other intersection is, we need to move our guess over to here. The other intersection is -3. So this is going to be the integral from -3 to 3 of, it's pi times, so the area of each semicircle is pi r squared divided by 2, where r equals 20 over 1 plus x squared minus 2 divided by 2. That's what's going on here. So it's the integral from -3 to 3 of pi times 20 over 1 plus x squared minus 2, all divided by 2, squared over 2. We have to be very, very careful about how we enter this. It's very easy to mess it up. So we're going to enter it into the calculator. It's going to be the integral from -3 to 3 of pi times, we're going to put our r in parentheses, and our r is 20 over 1 plus x squared minus 2. Oh man, I should have done a big fraction here. Hold on. We're going to delete this. Let's make it look right. Pi times all right, I'm going to put another fraction here. It's 20 over 1 plus x squared minus 2 divided by 2. That's our r squared. And that gets divided by 2. It's pi r squared divided by 2. Look how ugly that is. And there's our answer, whatever this is. It's going to take it a second. Oh wait, no, something's wrong here. Something's very wrong. Look at this. See how easy it is to mess this up? I'm not sure I squared the r correctly. Let's make sure we have parentheses correct here. I'm not sure this will matter, but that's what's being squared. I think it's going to come out the same. But I'm worried I didn't type it into the calculator right the first time. Yeah, okay, it's right. It just changed it on its own. So that's what it is. Remember that we need to put it to 3 decimal places. So that's our answer. Okay. Hopefully that helps.